Okay, I just wanted to go over a couple of things with you about this height lab. First of all, as you work through this height lab and you're having each team member get their resultant length and their angle, when you measure your string, you want to measure it about 1 foot to 1.5 feet above your head so that when you use it, you can stretch it out and you can get a nice tight or taut string so that you have an actually correct measurement. So you're going to stand with the floor. That string is going to go right at the top of your head, not on the middle of the top of your head, but right like at the top of your forehead where it meets your head. And you're going to bring it down to the floor as such. Once you have it down to the floor, you're going to want to put a piece of tape here. You need to measure this angle. So this is theta. You need to measure it. It should be somewhere between 45 and 55 degrees to work at its best. So you need to measure it, and then you have to have a theta number 2, which is equal to theta plus 6 degrees to make up for the difference between the floor and the protractor. So you will end up in data table 1. You can actually subdivide this and put your first angle and your second angle. This one will be the plus 6, and this will be your original angle. So you'll actually have 2 angles in there. You'll also, once you've finished, you step away from this. You have the floor, and you'll have your piece of string along the floor to the tape. You want to measure this, and you want to be sure that it's a nice straight line. It should be measured in meters. So obviously, you're going to use the meter sticks. You're going to get an answer in centimeters, and you're going to record it in meters right here. You're going to work through this and have data for all 3 people in your lab group. So names should go in here. The data from up here should be carried down. The one thing that you need to add up here is tape, because you'll need to use tape as you tape it to the floor. So when we look at this, the string is the what leg of the triangle? Is the hypotenuse of the triangle. Or as we say in physics, this length of string is equal to your resultant. This length of string is equal to your, this length of floor is equal to your x component, and this leg of the triangle is equal to the y component, which is actually your height. Now, I will warn you, you have to be very, very careful when you take these measurements, or when you measure this string. You have to be extremely accurate for each person. When you measure your height, when you get to the part where you have to measure your height, you want to do that today. It is located on, it's not until this 3rd page of the lab handout. But once you have all of your resultant information and your angles, the next thing you need to do is to go to this 3rd page of the handout where you need to get each team member's height. This should be in meters. What you want to do is back up to one of the doors in the room that's flat. There are the 2 doors that lead. One leads outside, one leads to the chemical room. Or you can also use the doors along the that would be along the hallway into just like the cabinet that keeps all of my equipment in it. So there's one flat door there as well. Use one of the 3. Measure each of your teammate members very carefully. Place a piece of tape where the top of their head is. Have them, and then have them move away. Back up to it. Use a pencil or something to mark that tape. Then back away again and do your actual measurements. Be sure that when you're doing your actual measurements, they should follow the rules. Follow the proper rules for measurement. Remember to estimate your last digit. I believe, well, we did on Friday. You should be able to get through the lab, get all of your measurements and everything. Once you have all of your measurements, because you probably won't get all calculations done today, then you can move back and you can do your calculations. For each set of calculations, you're going to divide this. This will be for your angle. This will be for your angle plus 6, all the way down. So you're going to have 2 x components, 2 y components for each person that you can then compare when you do your percent error. So these are all the original angle. These are all the original angle plus 6 degrees. So you need to do 2 calculations for each. You're going to use the vector resolution, the second type of vector resolution, where obviously you have your R and you have your angle. So you have to figure out how to use those 2 numbers to get these sides of your triangle, your Y and your X. Once you've done these things, then you should be ready to move over here and to calculate percent error. When you calculate your percent error, your actual is the real height that you measured against the door. Your experimental is what you did with the string and calculations. So you're going to have 2 sets of percent error. So we're going to divide this. Your resultant stays the same every time. Your actual height stays the same. You'll have 2 x components, 2 y components. Again, theta, theta plus 6. Same way down here, percent error, theta, theta plus 6. And you're going to use those numbers to calculate your percent error using the formula here. Remember, percent error is an absolute value. There's never a negative percent error. That's why we have that in the absolute value bars. So don't forget, you won't have a negative number here when you work through it. I believe you'll get through lab today, and then your hybrid work for tomorrow will be to do all of your calculations. And yes, you're to do calculations for not only yourself, but for all your team members. And those things will be due on Wednesday. Thanks. I hope you guys have a great day.